Okay, so we continue to look at the fundamentals of precalculus. This time around, we look at the rational expressions. So this is just an expansion of what we looked at last time. Last time we looked at the algebraic expressions. So this is just a component of these algebraic expressions, except this time, instead of having one, we're having two. We're trying to make two, okay, that are going to form a ratio. So we can define these as a ratio of two expressions or two polynomials. Okay. Okay, so this is a system of terms. Okay, polynomial would be maybe something like x squared plus x plus 1. That's a polynomial. Okay, let's put 1, 2, 3 terms there. So a rational expression will have maybe two expressions. There'll be an expression on top here and an expression below here. So we'll have maybe x plus 1 over x plus 2. So this is a rational expression. So why is this concept important? This concept is very important because mathematics usually moves from complexity to simplicity. Okay, so anything we try to do, we try to get to either one number or a very simplified form of either the equation or the expression. So when we simplify maybe a system of equations, or we simplify, let's say, you simplify an equation, or you simplify an expression, eventually it needs to get to maybe something like an equation like this, a straight equation, or a single expression, or you can get to a rational expression like this. Now from here or from there, that's when you apply the mathematical concepts. Could either be trying to integrate it, or you could be trying to differentiate it. Depends on what you're trying to do. So these are what we'll look at in future. But for now, we just need to understand that all these things that we've done, the exponents, the radicals, they help us to see all these patterns. So now we have this expression here. Okay, remember when we looked at rational expressions, rational numbers, we said that they were a ratio of integers like this. So this is similar when we talk about rational expressions. And then now, so this is just a reminder. So this is an example of a rational number. Okay, so this is an integer and that's an integer, so we make a rational number. Then these would be examples of rational expressions like this and like that. So another important element of expressions is the domain of the expression. So the domain simply is a set of solutions for an expression or an equation that are valid. Okay, they give you a valid equation. So for example, here, if I look at this expression, where is it invalid? It's when I put a 0 here, because that will give me division by 0. Even if you were to put this into your calculator, this will not give you a solution. So therefore, we can say that x is such that x is not equal to 0. That will be the solution. So here, this you read as such that. So x is such that x is cannot be equal to 0. Okay, so that's the domain or the solution set for this one. So meaning that I can put a 1, I'll have a solution. I can put a -10, I'll have a solution. But if the moment I put a 0 here, I don't have a solution. Same here. We'll have to think of anything that can make this invalid. And we know that it's negative numbers. So I want to avoid negative numbers in my solution. So what do I say? I will say that x, okay, is such that x is greater or equal to 0. So I can put a 0 here, I get 0. I can put a 1, I get a 1. I can get a 2, I can put a 2 here, I get the square root of 2. So the only thing I can't put here is a negative, okay, because that would give me imaginary numbers. So for example, if I said square root of -4, that will not give me a solution, a real solution. So that would be 2 root -1, which is equal to what? 2i. So that's imaginary. So same here, okay. If I look at this, I will look at the what does it give me? Where must I not put? What can I not put here? So I'll look at first of all, I'll look at the 0. I cannot put a 0 here. The moment I put a 0, I'll have an invalid solution here. What else can I not put? I cannot put a negative number. So now there are two things. So that will make the solution quite different from this one. I cannot put two sets here. The first is I can't put a 0. The next is I can't put negative numbers. So what is that combination? So that combination would be my solution needs to be anything above 0. Okay, meaning that I'm avoiding 0 and negative numbers. Now, it gets complicated, obviously, more than this. But this is something, for example, now you have these two equations that are similar here and here. What would be the solutions here? Okay, so I look at this equation here. There's nothing that is major that I must avoid here. So my solutions here are going to be all real numbers. Okay, all numbers here. They can work here. Then what makes this different? So for this one, I need to, what would make this invalid? First of all, I have to look at the denominator. So anything that equates this to 0 makes it invalid. I don't have to worry about this top part here. So what makes this invalid? So I have to solve for this, okay? Plus 6 is equal to 0. There's a video that we did on simple quadratic equations. You can check that if you want to have more practice. But we'll solve this step by step. So here, what we look at are two things that we discussed. There's product, and then there's going to be sum. Okay, so the product is, I get the coefficient of this guy here. I multiply with that. So that's 6. Then I look at, so my product is 6. Then the sum, I look at what two numbers I would be able to add or subtract that if I multiplied would give me a 6, and if I added would give me a -5. So already I can see it's 2 and 3, okay? But this time around, they need to have negatives, both of them. So I can say -3x minus 2x plus 6 is equal to 0, right? So I have to say, I have to factorize an x there. I have a 3. And you can see that where you're going, you're actually going somewhere if you see that you're getting the same factor here. So I get these which are outside, I put them together, okay, outside the brackets. And then I have this, or I factor this one out. Okay, so I have that one here. Then I can solve for, so any of these two can give me a 0. So I can do that as 0. -3 can also give me a 0, right? So now I have x is equal to 2, and then I have x is equal to 3. Both are positive, okay? So you can see that when you have these two, that is equal to 0. And we say that one of the things that we need to avoid is dividing by 0. So now we can say that our solution set is going to be everything. Okay, it's going to be everything except x must not be equal to 2, and also x must not be equal to 3, like that, because the moment you put these into that equation, you get a 0, and that will give you division by 0, which is not acceptable. Now we can look at the simplification of rational expressions. We've encountered some, but that was not maybe a formal introduction, but now we look at the formal introduction. So, for example, if I've got an equation, or maybe expressions like this, rational expressions like that, these we can simplify like that. So our end expression would be like that. So for example, if I had ACD over DCB, okay, then I can simplify this, simplify that, then I get A over B, like that. Okay, so an example maybe here would be if I had x squared minus 1 over x squared minus, well, let's say plus 2, let's say plus x minus 2. Okay, so we are going to try and simplify this. If you remember the factorization of this one, we get this, okay, and then we get that, like this. Then if we try to factorize this, we can look at the product. Product is minus 2. So what would give us minus 2? If I had to look for 2 that could give me a sum here of plus 1, it will be minus 2, it will be plus 2, and minus 1. Okay, so this gets to x minus 1, and then x plus 2. That's the simplification of this. Then, so I can cancel this, I can cancel that in a similar fashion to what I did here. So you cancel this and you cancel that. You can see here I've cancelled this, I've cancelled that. So eventually we have x plus 1 over x plus 2. So we would have simplified that that expression here. All right, the next thing that we look at is maybe multiplication and division of rational expressions. So if I had something like P over Q times X over Y, like that. So this, when it's multiplication, it gets to that. So it's Px over Qy, just like that. When it's division, let's say I've got AD, or let's say AB, divided by CD. Okay, just the normal thing that we normally do with multiplication applies here. So we have A over B times D over C. So our eventual answer here becomes AD over BC, like that. So we can look at the examples. The first example being this one, x squared plus 2x minus 3 over x squared plus let's remove this, plus 8x plus 16, and then we are multiplying by 3x plus 12 over x minus y minus 1. And we said that one of the most important concepts to understand is that in mathematics, what we are just trying to do is to simplify and then apply mathematical concepts. So you can't really apply, even if I were to integrate this, I mean, I wouldn't want to integrate this in the form that it is in right now. So I need to be able to simplify. So I start with this. Again, you have to be very good at factorization. So here, I know that the product is minus 3, the sum is plus 2. So I know it's 3 and 1, right? So here I have x minus 1. Then I have x plus 3, like that. Then I come this side. I know that this is a square of factors. So I've got 4 and 4 here. The sum 4s and then the square of 4s. So I can say it's x plus 4. And then this is x plus 4 as well. Then I'm multiplying this. So that becomes I will factorize this as well. Okay. And then I'll continue with this. Now we gave an example here before this one where we were cancelling some of these to simplify. So I can cancel these two. Then I can also cancel any of these with that. So then we do the multiplication now. So that's 3x plus 3. That's what's remaining on top. And then at the bottom here, we can say that it's x plus 4. I can now leave it in this format, or I can expand this over 4, over x plus 4, like that. With division of rational expressions, like showed earlier, we could have something like a d, okay, divided by, let's say, b over d. Okay, so we initially spoke about this where we said that this needs to flip if you're dividing, or it needs to invert. So that becomes d over b, like that. So you can cancel this, then you get a over b. And so this is the most important part that differentiates it from multiplication. And so now we look at an example. An example would be, let's say I've got x minus 4. Okay. Then I have x squared minus 4, like this. Then I'm saying I'm dividing this by x squared minus 3x minus 4. Okay, this example is from the book. Then x squared plus 5x plus 6. So you can see that all the concepts we looked at already play a vital role when it comes to these. So here, what am I going to do? I'm going to maintain my x minus 4. And then what else can I do here? I'll simplify this. We know that this is the difference of squares. So it'll be like that, minus 2. And then this one will be plus 2. I then multiply, okay, because then I flip these. So this one goes and becomes the numerator, like that. And then this becomes the denominator. It's minus 4, okay. Now what do? This remains in this format, so I just maintain it like that. So another key is just knowing what am I going to redo and what am I going to change. What am I going to write just in its same format, and what am I going to change? I think that's a very important add. So here we can simplify this. How do we simplify this? We know that the product is 6 and the difference is 5. So already I know that I can use 2 and 3. So I have 2, then I've got x plus 3. Okay. Then here again, I multiply these. I get a product of minus 4. And then how do I get to 3 if I use minus 4? I can use, remember this is minus 3. So I can get to 3 using minus 4. So, and then I use plus 1. Okay, so the plus 1 like this. So plus minus 4 times 1. That gives me minus 4 as a product. And then if I just add them like this, they give me that. So it means that I can simplify this into these two. This is where you have to be very good with the signs, remembering what is where. Then I can simply cancel these two. I look for other terms I can cancel. I can cancel those two. Okay. Is there anything else that we can cancel here? I can't see any. So I'll return this, the x plus 3. I'm going to return it just where it is here. And then I'll return the x minus 2. Because this is cancelled, then I'll return the x plus 1. Like that. So my final answer here would be this equation here, this expression here. Addition and subtraction, they follow the same route. So it's just about recognizing the lowest common denominator. So here, if for example I had 3x minus 1 plus x over x plus 2, like that, I'm just going to have to find the lowest common multiple here. Okay, so if I divide that into there, I have this remaining. That's the one I multiply on top here. And then the same thing happens here. I divide this into that. Then I multiply this by the numerator. Like that. What follows is expansion. So here we have 3x plus 2 plus 6. Okay, so we have to be careful there. Then plus x squared minus x, like that. Then we maintain this structure here because we don't know what's coming here. Okay, so I have my x squared because that's only power of 2, and then my 3x and that x there can work together and give me 2x. Then my 6 is single, so we can put it there. Then what's next? What's next is I can return this just like this. Or if I want, I can actually expand this so that it's in the same format as this one, because I can't simplify this any further. Okay. So this is one way. So you see, when we get to, let's say, integration or differentiation, you see that you can't work with this in this format. So you have to also learn how to um, convert this into, let's say, partial fractions. So you see, everything is about simplification. So once you get to this point, then you have to be able to reduce this into partial fractions so that your differentiation could work, or your calculus could work. Okay, so this is addition. What about subtraction? So an example of subtraction that you can have is this one here. Okay, so this one, then I'm subtracting now. So this is where the difference is. I've got 2 here, and then I have x plus 1. This is squared. Takes us back to the same thing. We need to find the lowest common multiple. So I'll first have to expand this or factorize this. So if I factorize this, it gives me x plus 1 and then x minus 1. Okay. Then together with this, or let me not first include it. Okay, let me have them as separate units. So here I still maintain my 1, then here I subtract this. So this will be like that. I still square. So I find the lowest common multiple here. So I know I'll get this. And then in my mind, I already know that this is a factor of this one. So I'd rather I get this one instead of getting this one and that one together. Okay, because that'll be a repetition. So now I can divide this into there. And what do I get? I get 1. So if I divide this into there, I have x plus 1 as a factor that will remain. Then I can multiply the numerator there. Then I maintain my minus here. I have to bring that down. You saw here I brought the plus down to here. So we have to be very careful with this. What do I do here? I get this and divide into there. Then I have what? X minus 1. So I have my 2 here, then x minus 1 like that. So I make sure that I've written it correctly before I start my my manipulations. So here I can do x plus 1. Then here, what do? I can have 2x minus, so this is 2x plus, that becomes plus 2. Okay, so remember what you have there. So now what do? You maintain your divisor. Okay, you maintain your divisor here. So what happens here? I subtract this and that, and then I add this and that. But I have to be careful because this will give me a negative x. So I want to be clever and put a positive first and then a minus there. Then I can simplify this like this. Okay, so that will be the final thing.